We may summarize the strategy for using the second law to solve the problem as follows. There are 4 steps to apply the Newton's laws to analyze the problem of the motion of a particle. First, you have to conceptualize. Draw a simple neat diagram of the system. The diagram will help to establish the mental representation, because if you can see the picture of the problem, it's easier to analyze the problem. Okay. Establish a convenient coordinate axis for each object. This is important. The convenient coordinate axis is the coordinate axis that make it easiest to solve the problem. So you have to look at your problem and decide what is the coordinate system that you should use to make it easiest to solve. The second step is to categorize. If an acceleration component of an object is 0, the object is modeled as a particle in equilibrium, as we have discussed, and the net force is 0. If not, it means that the acceleration is not 0. The object is modeled as a particle under a net force in this direction, and we have that the sigma f is equal to ma. Since the force is a vector, you can do this step separately in each direction of your coordinate axis. Okay, you may have that the acceleration is 0 in the x direction, but not 0 in the y direction. This is obvious, for example, in the case of the projectile. So you have to categorize that your problem is equilibrium problem or not equilibrium. Next, the step of analyze. Isolate the object whose motion is being analyzed. Draw a free body diagram. This is a useful diagram for this object. For system containing more than one object, draw separate free body diagram for each object. This makes you less confused in your analysis. Solve the problem separately for each object. Okay. Do not include the free body diagram forces exerted by the object on its surrounding, because now we are looking at the motion of the object. So the forces must be the force that act on the object, not the force that the object act on its surrounding. So be careful on this. When we want to analyze the motion of the object, the forces is the forces that act on the object only. Find the component of the force along the coordinate axis. Apply the appropriate model from the categorized step for each direction. This is what I explained before, that since the force is a vector, you can separately analyze your problem for each coordinate axis. And if the net force on that component of the coordinate axis is 0, you have the equilibrium problem. If not, you have to analyze the acceleration and the velocity and the position. Okay. Check your dimensions to make sure that all terms have units of force. This is a very useful step. You have to keep in mind about the direction of every quantity. as we mentioned in the first chapter, that the physical quantity must have dimension. So when you write down the Newton's law, on both sides of the equation must have the dimension of force. So this will this can guide you that your analysis is correct or wrong. If the dimension is not agree, it's wrong for sure. But if the dimension agree, you have to go further to look at the numerical value or the algebraic expression of your result. Solve the component equations for the unknown. Remember that you generally must have as many independent equations as you have unknowns to obtain a complete solution. This is the rule for the algebra. If you have two unknowns, you need two equations. If you have three unknowns, you need three equations. So you have to be you have to look at your problem. If you have n unknown, you must find n equation to solve those unknowns. And finally, to finalize your analysis, make sure that your results are consistent with the free body diagram. As I mentioned before, the free body diagram will give you the idea of the magnitude and the direction of the net force. So after you do your calculation, you can compare your results with the free body diagram again. Also, check the prediction of your solution for extreme values of the variables. By doing so, you can often detect errors in your result. Sometimes detecting error is not so easy, but it can be helped if you take some extreme value of your variable that it make it very small, make it very large, and if you know for sure the solution for that extreme cases, so you can check that once you put the value of the variable to be so small or so large, and you can check your results with the answer that you already know for that extreme cases.